blood typing is hilarious. And it really does help understand a little bit about blood typing and transfusion reactions, which is a key learning objective for this content. You get 3 times. So once you do it, you can then go back without leaving the game and do it again, and the person will be a different blood type the second time, and then a different blood type the third time. If you know it really well, go back in and do it wrong, because yes, it is hilarious when you kill the person. Like, they scream and ah! But anyway, so there is a link right on the content if you want to have a little study break and go do some blood typing. But blood typing and knowing how to identify the agglutination is important for this content, and then understanding the antibody-antigen reactions are important for the content. All right. So I have a multiple choice question, and I've set, not breakout rooms, don't want to do breakout rooms, polls. I created a poll that I hopefully can continue to use. It's available right in Canvas, so I'm gonna maybe walk away a little bit from Socrata for today at least. This has popped up in, not Canvas, Zoom. It's in Zoom, it's right in front of you on Zoom. An individual has had the flu for 3 days with severe vomiting and diarrhea. How will this affect his hematocrit? Oh, I'm going to share. I'll share so you can see it. Sure. People are probably like, how are they answering? There you go. So it's on the PowerPoint that's in the sync session for today. But now I'm sharing. I'm trying to get that participation. Oh, great to see everybody's camera on. Okay. All right, we got almost 91% participation. Why'd you do it to everybody? Okay. All right, I'm sharing the results. So pretty kind of all over. So we got 36% for A, 57 for B, and then pretty low for C. It's only 8%. So if you think about this, there shouldn't be anything with this individual that changes their number, the number of RBCs. Do we kind of agree with that? Right? It's not like they're bleeding out. It's not like anything's going to affect the number they have in their circulation. Right? But what are we doing? Whoops, sorry. Vomiting, diarrhea. Yeah, so they're going to have volume loss. Dehydration. Right? That's what happens when you get sick and you have to eat the Pedialyte and everything. So it's a really great way to introduce, do we know what a hematocrit is? Your hematocrit is a ratio. So if this is my test tube, it's the ratio of fluid or water in your blood, in a blood sample or a circulatory sample, which we know the fluid is the plasma, compared to how many cells there are. So the blood cells, the packed cells, those are my blood cells. It's a ratio. So if you become dehydrated, then the blood cells take up more of that ratio. So the answer to this one is B. It is B, and it did predominantly well there. Matthew, I'll get to your question when we cover that, okay? My general answer is no. All right, so how do we feel about this? Good? Okay. Let's do a little bit of key facts. On the next 3 slides are really very factual, condensed stuff from the PowerPoints. Erythropoiesis. This is making RBCs. Dr. Corso is going to talk about it too. So know the shape, the structure of it. Where do we make it? Well, typically in adults, we make it in a few of our bones, not all of them. We don't make it in our long bones. We make it kind of like in your ribs, your sternum, your soft, I don't want to say soft bones, those bones. Fetal, you can actually make it in your yolk sac and then the liver, and more of your bones make red blood cells during fetal development and then even into as you're younger. But in adults, it's only certain bone marrows like the ribs and the sternum are the main ones. Vertebrae. What do these little Greek letters mean? What are these Greek letters standing for? This is a good Corso question. Why do I have 2 alpha, 2 beta, alpha 2, gamma 2? What are those? Beta. What are those? So what does that mean? Alpha 2, beta 2, alpha 2, gamma 2? What am I talking about there? What protein are they referring to? Somebody's written subunits. What protein are they part of? Okay, yeah, babies have gamma. That's right. It's their hemoglobin. So yeah, these are the hemoglobin subunits. Hemoglobin. And yes, especially during respiratory, remember we talked about how the fetal hemoglobin, not so much baby, fetal. Yep, more affinity with the gamma subunits. But hemoglobin, major protein in our red blood cells, carries oxygen. Okay. What do we need? So we'll just kind of start here. You can fill up the chat. I'm going to stop sharing this in case it's covering people's screens. What do you need to make a red blood cell? So the question here at the bottom. What are some things we need? It can be anything that's on here. What do we need? EPO, yep. Iron, EPO. B12, folic acid, iron. I like the Gram stimulating factor. Colony stimulating. All right, so good stuff. First thing, we have this pluripotent stem cell in your bone marrow we'll go with. It can become a white blood cell, it can become a red blood cell, it can become a thrombocyte, it can make platelets. In order for it to kind of form into what's going to be destined to be a red blood cell, we've got to trigger it. We've got to send it that way. And a couple of people, I don't know if they put it to everybody, but GM-CSF. So we get these colony forming factors, colony stimulating factors, and that's going to help this pluripotent stem cell be destined to become a red blood cell. Now we've got to get the other stuff. EPO. Yeah, it's pretty much on this one. EPO is needed to take that colony that's formed now and get it to begin to develop into a red blood cell, erythrocyte. All right, where do we get EPO from? What organ in our body makes EPO? I got a bunch of answers coming in. Kidney, kidney, kidney. Okay, so now if you've answered, you can't answer again. What is the stimulus? What stimulates the kidney? to make EPO. Okay, so feel free to like answer to everybody. You don't have to answer to just me. Hopefully you can answer to everybody. Yeah. So I got a couple people said oxygen. Juan, I like Juan's better. Low oxygen in the blood, so hypoxia. And then your kidneys produce EPO. EPO goes to the bone marrow, stimulates this differentiation of the red blood cell. So then some other requirements that folks listed to me, I don't know if to everybody, but we got B12 in there, we got the folic acid in there, we got iron, we can definitely see that iron dependence here. And that iron dependence comes once we start to develop the erythroblasts and get that hemoglobin. Notice hemoglobin is starting to come at this stage as we get between that 15 to 20 day stage. So that gets us into that. Unique feature about red blood cells, they have very few organelles. So they don't have all the Golgi and all that. Very few organelles within them. And they start to go away as the erythroblasts develop. That's a lot of the key, a lot of facts, just little memorizey facts there. I think it'll pop up on, I thought it would pop up on top. But, so there's a cell that gets developed before we get mature red blood cells, and it's right here. It's a reticulocyte. Kind of see them right in here. They look almost like red blood cells. And then they become red blood cells. It's about a day or two beforehand. And we use this. So we've got a little bubble here. What would, or what does, elevated reticulocytes in the circulation mean? What could it clinically tell you? Again, don't just send it to me. Send it out, even though I think this person's answered a bunch. If you haven't typed an answer in yet. Okay, Eric and Keaton. Could be blood loss, because that means you need to make more, so you would be hypoxic. Yes, so that could be a very clinical thing. Do we measure reticulocytes at any large international events that occur, say, every 4 years? Okay, it could mean RBCs are lysing more than usual. Yeah, you're losing RBCs. Athletes at the Olympics. So somebody said to me, blood doping. So one of the ways we used to blood dope, not used to, people did, is you would inject yourself with EPO. So let's say I have good levels of red blood cells. I'm fine. I'm normal. Nice normal hematocrit. Well, if you inject EPO, that's going to increase the production of red blood cells. And you can overwhelm the bone marrow a little bit, and you're going to start to get more and more reticulocytes coming out. Now that can happen. We do, if somebody's lost blood, maybe for certain cancer treatments, blood loss, maybe I am going to inject you with EPO, and that's going to give you more blood synthesis, but I'll know that you've done that because of elevated levels of reticulocytes. So it's almost like when you tell the bone marrow to make more, it makes more of even the immature ones, and that can be an indicator. And if you haven't watched the video yet, I go into quite a story about Claudia Pechstein. It's more maybe interesting. There's not going to be a test question on her, but it's kind of interesting. So then we make our red blood cell. There they are. What happens to them? So where are we? Right here. This is where we ended up. Make them in the bone marrow. New ones come. Some of them die or hemolysis right away. But most of them, 90% of them at least, circulate around for 120 days. Well, then eventually, because you know what? Our capillaries are really small and these red blood cells just sit there and go like this through the capillaries constantly, the spectrin, which is the main cytoskeletal protein in our red blood cells, it kind of think about it just breaks. It's taken too many compressions. So then we degrade it, but we are, and I know Dr. Corso probably goes through this. We went through it in GI. So this is a little bit of a review just from GI. I won't say it's our last system, but recently last. We break it down, macrophage. I bet if I asked you in the liver, who's got a good memory, we can't forget. What are the macrophages in the liver? I think Dr. Austin asked the question. I asked it. Macrophage in the liver that degrade our heme. Yeah, the Kupffer cells. So those are those ones that are there. But they break it down. The amino acids we'll just reuse. Why waste? Iron. We definitely reuse that iron. And we talked in GI that your intestinal enterocytes will store iron. And if you don't need it, they'll just slough off and get rid of it. If we do need it, then we'll take it off and put it on transferrin and use it to make red blood cells. Bilirubin, again, I'm not going to go through this. It literally would have been 2.5 weeks ago, 3 weeks ago maybe at the most, that we went through the bilirubin cycle. So bilirubin gets into the intestine, out through the liver. So that's how we can get rid of it. But this is the life cycle of the red blood cell. A lot of it's review. Everybody okay with this one? So that's the normal phys part. I do like the HEMA because it kind of gets us into a lot of application. So application, pathophys. This will go very nicely with the therapeutics. It's the anemias. So anemias are predominantly classed based on the size of the red blood cells. Okay. So normal size red blood cells here and normal number. So we got good number and we've got regular shape. So they're normal. Definitely look at the number of red blood cells in these pictures to kind of help. Well, then sometimes you can have low numbers but big cells. This is macrocytic. Macrocytic anemia, I'm just now opened up the flow chart that's next to it. So if we have macrocytic anemia, so that means our mean corpuscle volume, the V, hopefully I'm going on you watch the videos. The V stands for the volume of the red blood cells, and they're a little bit bigger here. See how they're bigger, larger size. That is macrocytic anemia. What can cause it? I'm going to highlight the ones I'm going to stress that you know the key causes. You don't have to know everything. But the big one for us here, B12 deficiency, folic acid deficiencies. How could you get B12? We can't forget what we did. Now this is probably more like 6 weeks ago. What cells are very important for allowing your body to absorb B12? What cells do you need to be functioning properly to absorb B12? Who am I going to call on? Okay. So good connections. I got intrinsic factor. Intrinsic factor isn't a cell, it's a protein that's secreted from parietal cells in your stomach. So during GI, I don't know how much we talked about it, but there's pernicious anemia. Pernicious anemia is anemia due to a lack of intrinsic factor, and pernicious anemia will result in a macrocytic anemia. What else we got? Microcytic anemia. So microcytic anemia, smaller, and I think they look smaller, and there's fewer. Microcytic anemia is when the mean corpuscle is smaller. So we can look at the size of those. And you know, it might be smaller if you think about it, maybe because the hemoglobin doesn't develop well. And, microcytic anemia, I'm just going to go low, normal number. So this means the hematocrit is also low. So you have a lower number of red blood cells. So that's the anemia. Follow my purple. Main causes for this one that I would care about, really, I mean, I'll be honest. I'm only going to want you to know that it's the iron deficient anemia. The therapeutics might get a little bit more into lead poisoning or inflammation anemia, but iron deficient anemia is a microcytic anemia. So that's a good one to memorize. Normocytic anemia. So in normocytic anemia, that's almost really straightforward. Normal size cells, but you don't have enough of them. It's still anemia. Hemolytic anemias can cause this. So hemolytic anemias here, they are predominantly normal sized. You might get some that look a little funky, and you may get more reticulocytes with hemolytic. But one of the major causes of the normocytic anemias are bone marrow. So hemolytic bone marrow disorders. I go there. Blood loss. Whoops, I'm crossing it out. So those are the main three for me. So what is bone marrow disorders? If you've watched the videos, there's mention of aplastic anemia, hypoblastic anemias. Anemias that are due to deficient bone marrow function. Those are going to cause your normocytic anemias. Blood loss. Well, when you lose blood, you lose red blood cells. Then you don't have enough around. You'd be anemic, but the ones that are remaining should be pretty normal sized. Finally, there's a little bit in the PowerPoints where I go over a bit about thalassemias, but thalassemias do tend to result in an increased amount of hemoglobin, an increased number of red blood cells, but they're usually smaller. So thalassemias can result in smaller red blood cells. Okay. All right, let's do some more fun. I know you don't think it's fun, but I'm going to relaunch, and let's do the first question. You know I love these graphs, right? So I'm going to help the graph out. So it's just a comparison. We've got the hematocrit and the EPO. C is normal, okay? So this is normal. There you go. Remember these from endocrine? There were things that looked like this in endocrine. Remember the graphs from the test? Aplastic anemia. Oh, we don't have good answering yet. It's looking pretty good. I can tell you the 50-50 split, at least I'm going to be confident everyone knows what anemia is. I feel confident we've got the anemia down. Let's get a little more participation in here. A little more participation. All right, we're up to about 75%. Ending poll. I feel like I'm making good eye contact. Nobody knows who I'm staring at on the screen. I'm going to share the results. And I'm going to ask Lena, what did you choose? Just to get the conversation started. Did you just go away?
No, I'm here.
What'd you choose?
A.
A. Okay. All right, so A. With A, we have a low hematocrit. I like it. So we know that we had to choose between A and E. Okay, and I'm going to share, look, A. 63% chose A. If somebody has anemia, what's going to be their O2 levels? What do you think that oxygen content? Low, right? So let's go with that one because this helps. This one did not do great. We're going to think about it, and now we're all going to get it. So let's go to the other fact. We know we have low O2. What will happen to the EPO levels because of this? No. Right, there we go. No. So this is a great question. I like that there's nothing wrong with the kidney. I didn't say there was anything wrong with their kidneys. So this is like, remember in endocrine, we had like primary disorders and secondary disorders. If we go back to endocrine and remember the hypothalamus and the pituitary, and then I'll say thyroid. Remember, if the thyroid wasn't around to make thyroid hormones, what was the level of TSH? I bet you all could answer that. It was high. So, aplastic anemia is very specifically referring to the bone marrow being the problem. So the answer to this one is the hormone that stimulates is going to keep pushing on that gas, but the car doesn't go anywhere because the engine doesn't work. Think about it that way. So it is going to be E. E for that one. Now that should help us with the next one. So I'm going to stop share, relaunch. Now we have end-stage renal disease. End-stage renal disease. It goes right back to the explanation we just had above. All right, once we hit the 75. All right, who's getting the magic? Okay. All right, most have answered. I'm going to end the poll, and we're going to ask Allie, what'd you put?
I put A.
Good. Yeah. Good just-in-time learning. So, end-stage renal disease, they're going to have low EPO because their kidneys aren't working, and that low EPO is going to result in a low, I don't know why I keep doing the L down arrow, low hematocrit. So low. A. All right, we're going to do the next one together, not as a poll. Erase everything. Polycythemia vera. So first off, let's answer the hematocrit question with polycythemia vera. High or low? High. That is what it means by definition. Okay. So now we're here. Okay. This question, actually, I can't just have 3. I've got to give some quantifiers. Because if you've watched the video, B or D could be correct. Let me say if let's say it's due to altitude. Altitude is the cause. What's the answer now? Yeah, because if you go to altitude, you will have low O2, which will lead to an increase in EPO, which will lead to an increase in hematocrit, HCT. So if it's altitude, then it's going to be D. Now, what if it is due to cancer of bone marrow? Not super common. Leading to an increase in RBCs. Now what? I think now it's obvious. Yeah, because then with the increased RBCs, you'd have a increased O2 content, and that would lead to a low EPO. Kind of see how the connection here with EPO being the hormone, think about it as that stimulating hormone that affects red blood cell synthesis, just like TSH affected the thyroid gland, like ACTH affected the adrenal gland and cortisol, kind of that logic there. Okay. Blood typing. Play with the videos. So the one thing, I'm going to go just down to this one. All of our red blood cells, every red blood cell in your body, well, yeah, most of them, they have proteins coming off them. These proteins on their surface are called antigens. So that's the first thing. Surface antigens. Your body, this is the key thing, your body produces antibodies against those antigens. That's kind of the key concept you got to get straight a little bit. So I'm going to give an example. My blood type, which is good to know in case we're all in a car accident together, my blood type is O positive. So what antigens do I have on my surface? If I'm O positive, what antigens do I have? Okay, some people, I'm getting a mix. Okay, so I do have some. I do have one. It can call it the D antigen, but the D antigen, is also known as the Rh factor. So I have those on my surface. Okay. What antibodies do I have in my serum? Yeah. Yes. So I produce antibodies in my serum. I produce, anti-A antibodies and anti-B antibodies. Those are the ones I make. That's what's in my body right now. Okay? How do you know what my blood type is? How do I know what my blood type is? Well, at some point, probably when I gave blood, I don't know, or maybe when I was a baby, they took a sample of my blood and they put it on a slide. And remember, your blood cells have the antigens. And then they took antibody out of a bottle and added it to each little spot on the slide and mixed it up and looked to see agglutination. So that's kind of what's happening down here. Agglutination is when an antibody binds to an antigen and it causes it to lyse and rupture and clump all together. So antibodies binding to antigens cause clumping. You don't want your blood to clump. So you don't want to have antibodies against your own antigens. I don't know how well you can see these, but slide 1 or patient 1. What is their blood type? A. I agree. So look, here is clumping. So it clumped. So that means when I put anti-A antibodies on, it clumps. So the blood had that antigen. Now, I will make sure whatever you see on the test will be very, very clear. I usually ask some colleagues to look. So I'm going to say no clumping here, no clumping here. It looks pretty clear. Oh, excuse me. So yes, this is going to be A negative. All right, what about slide 2? Slide 2. I know what I would say. Maybe you got to get real okay, we're all good with B. It is B, for sure. I agree it's B. And honestly, if I look there at the D, I do see little red dots in it. So yes, I'm going to go with B positive. Again, anyone I give you on an assessment will be clear. What about slide 3? Can you look at these? Yes, I agree. We're getting a bunch come in. Oops. A, B, positive. Yeah, I think there's clumping here. There is dots there. All right, what about slide 4? Not Jody. Oh, sorry. All right, so we definitely go with O. So there's no A, there's no B. And I say O positive. I say O positive. I would say yes, clumps there. So definitely do the video. The video is kind of neat to go through and, well, I don't mean the video, the game. The game helps you see. Yeah, it's kind of a fun game. So yes, I don't mind telling you, there's going to be very crystal clear slides given to you and ask you to know the blood type. But on top of that, you know, I always like to take it to the next level. With these, besides knowing the type, put what antibodies would be present. So if you look at slide 1, we said they're A negative. So they're going to have anti-B and most likely will have anti-D antibodies present. You fight what you don't have. And lastly, it's for those transfusions. And the thing with the transfusions are you have So back to the original, I said I was O, so I had the D antigens, but I had anti-A and anti-B antibodies in my plasma, in my serum. So if I was transfused with type A blood, my antibodies would attack it. So when it comes to the transfusion reactions, it's about the antibodies in the person being transfused that causes the problem. They will attack the blood cells of what's being put into them. Okay, so that's kind of the key thing there. All right, so last little bit here, and then it's just a bunch of info slides. Hemolytic disease of the newborn. Matthew asked a question about it a bit ago. So a mom is Rh negative. So that means I'm just going to say, let's say she's O negative. I don't know what her A and B is, but let's say she's O negative. So she has no antigens on her surface. And the one thing, read, listen about the D antigen, the Rh factor antibodies, you sometimes won't get produce those antibodies until you're actually exposed to it. Whereas the other antibodies, anti-A and anti-B, you do start to produce at about 3 to 6 months. So let's say that mom gets with a dad that is, I'm just going to pick A positive. And well, the blood types work on normal Mendelian genetics. That's probably where you know about all these blood types, if you haven't done a lot of this in the past, is when you did Mendelian genetics in junior high. So there is a chance that even though mom is negative, dad being positive, the fetus could be Rh positive, because dad was. All right. Now, birth is messy. I should ask one of our classmates. And things get cut and blood mixes. So during the birthing process, blood can mix. And so now the mom is going to get exposed to a foreign antigen, the Rh factor from the fetus. As that blood leaves, there's going to be some blood mixing. It won't kill mom. She won't clot to death. But the mom is now going to start to produce the antibodies against the Rh factor. She's fine, because remember, once the baby's all gone, everybody's gone, she's Rh negative, they're not going to attack her, she lives her life, everybody's fine, and now she's got another defense system inside. Well, mom and dad have another baby, and the baby again is Rh positive. Mom's antibodies can cross that barrier. Mom's antibodies will bind to the Rh factor on the fetus's blood and can cause hemolysis. It'll burst, rupture, can cause death. Now, Matthew, you had a great question. Does this cause miscarriage? I'm going to say not in the past 50-something years, because any female that is negative, and I think even now, some of you probably might work in, even if it's their first child is given RhoGAM, second child for sure. Like, I'll put it in perspective. My mom was given RhoGAM because she's negative and my brother was positive first. So, I mean, we're talking a long time ago. So I don't think it anymore. It is not, unless maybe they don't know. So, miscarriage during the first pregnancy, somebody asked me about that. I think you would even just as a precaution, I mean, and right now it's every mom gets RhoGAM that's negative. It's really kind of a standard of care to prevent it. And mainly because, like, I know they don't do it anymore. The blood sisters, the chance of an Rh negative mom, even before the first pregnancy, producing that antibody, it's pretty high. Oh, there we go. I'm getting a lot of wonderful stories. All right, but I want to keep going. So that's hemolytic disease of the newborn. Finally, do you guys think this is like a hodgepodge 2 hours? It's like, let's take anything to do with blood and put it together in one physio lecture. The last bit is about hemostasis, which is the process of stopping bleeding at an injury. And there's a process to it. The 3 main steps. So once you cut yourself, the blood vessels spasm, so we get a lot of smooth muscle going on there. Endothelin is part of that. Serotonin is part of that. Then at that site, because there's damage, we start to get platelets sticking to those fibers that might be sticking out from the injury area. Like if you look right here, there's like little injury fibers kind of sticking out there. The platelets will stick to it. And then those platelets stick together and begin to release factors. They aggregate, they form a plug, and they release factors through a process called degranulation. And then these factors help in the creation of a fibrin clot. So the clot formation, I gotta erase that degranulation, is the process of forming this fibrin strand. And there's a lot of factors that are required for that to happen. I'm going to start with the extrinsic pathway. So these come from outside of the blood or tissue-derived factors, factor 3 and factor 7. Maybe if I write it like this, 3 and 7, yes, you do need to know your Roman numerals, lead to the activation of factor 10. And then factor 10 activates 2 to 1, and eventually we get fibrin being activated, and that creates that clot. So 3 plus 7 equals 10. 10's the one that goes down to get the fibrin. That's easy to remember. All the other ones are the intrinsic pathway. So the intrinsic pathway are ones derived from in the plasma, in the circulation. So here 12, 11, we're going to skip 10, 9 to 8, and then activated 8 along with activated 9 will combine to activate 10. So we have 2 merge points to get us 10. And we form the clot. The focus in the PowerPoint is primarily on what happens when you don't have these. Well, when you don't have these, you get hemophilia, meaning you can't stop bleeding. The most common one, right here, hemophilia A. Uncommon is kind of next, so hemophilia B. There is hemophilia C as well. Let's go back here. I went back a slide. Hemophilia C is not in my table, but it's right there. Hemophilia C is up here with factor 11. A is 8. You kind of remember hemophilia A is 8. Those are the main ones. The other ones are pretty rare. I do talk a little bit about von Willebrand factor in the video as being one. You won't get that agglutination or degranulation because that's what von Willebrand factor is doing. All right. So this is for the cases that you have. I'm not asking you to be diagnosticians and but you probably will remember from cardio. So it's really funny. Like this kind of stuff at the end should be in cardio. Do you remember doing coagulation cascading cardio? Especially if I mentioned the drug Xarelto. Do we all know where Xarelto is derived from? Factor X, factor 10, Xarelto. So you did a lot of this therapeutic stuff back in cardio. But that's for the cases. So you do have cases. They're open now. These again, don't want you to forget. These are just like before. So I'm going to write it out. I don't want to have any miscommunication. Handwritten, right? Handwritten and upload. Handwritten cases. Everybody remember that from GI? Write them out. And so I did make them due at 5 p.m. But I'll stick around. I would say at this point you are free to leave, but you're also free to work on these. I'll stick around for 10-15 minutes, answer any questions that you might have about them. I did see a comment from a student wanting me to go back, so I want to look at that again. They asked me about a specific slide, so start working on these. Can I get a thumbs up that you can see them and they're open? Okay, thank you. Okay. And I'm going to go back. I want to see the slide that somebody's asking me in doubt.
Dr. Jones.
Yes. I feel like I heard a whisper. Did somebody have a question?
Yeah.
Yeah.
You see that case today? Do you
Yes.
have
Yeah.
it written?
Yes.
No, it can be getting postponed tomorrow. The time they need plan out and time unwritten it cannot be today. My printer's not working, so I need to go to the office to get plan out. Or the library is no way today.
Do you have a tablet or a pad? A pad?
And that work with it.
Like an iPad? Do
I don't know if I can try, but it doesn't work that way. I need to print out all the print out.
I'm sorry.
If I print out doesn't, I don't know, my tablet doesn't work that way, but if I try, if it doesn't work, that means I need to print out tomorrow.
Tomorrow? That seems extensive.
Yeah, print out and handwritten and uploading like a GI paper doesn't work me today.
Well, do what you can.
Okay.
I mean, it's due at 5. So, I mean, you could, I'm okay if you handwrite on a tablet or anything, so. I'm just, let me get the one thing that I was asked about.